Chapter 3.2, Mean Value Theorem. This theorem basically states that if you have a function that's continuous on a closed interval a to b, and if that function is differentiable on the open interval a to b, then there exists a number c in the interval a to b such that the first derivative of the function is equal to f of b minus f of a all over b minus a. So for this first problem here, we have this function. First question we have to ask is it continuous on this interval? And yes, it is. So next question we have to answer is it differentiable? So to do that, we have to take the derivative. So f prime of x is equal to 3x squared plus 2. So now, is this differentiable on the open interval? So 1, negative 1 to 1, and yes, it is. So that means there exists a number c in the open interval negative 1 to 1 such that f prime of c is equal to f of b minus f of a all over b minus a. So next thing we want to do, let's solve for f of a and f of b. So f of a is 1 cubed plus 2 times 1, and that's 3. And then f of b, negative 1 cubed plus 2 times 1, and that is negative 3. And make sure that when you plug in these numbers, you plug it into the original function, not the derivative. And so now we have all the parts, so we can plug it into mean value theorem. F prime of c is equal to f of b, which we found to be negative 3, minus f of a, which is 3, all over b minus a. That's negative 1 minus 1. And now this is equal to negative 6 over negative 2, which is 3. Now, you're going to set this value equal to your first derivative. So, 3 is equal to 3x squared plus 2. Now, we're going to solve for x. So 3x squared is equal to 1. Divide that by 3 on both sides. X squared is equal to 1/3. Now, square root both sides. X is equal to plus or minus the square root of 1/3. Now, one thing you need to check is you need to check and see, are both of these in my interval? And yes, they are. And we can simplify this to x equals plus or minus 1 over the square root of 3. And they're both in the interval, so that's our answer. Now, next problem, same concept. Is it continuous on this interval? Yes. Now we have to find out if it's differentiable on the open interval, so let's take the derivative. That is just 12x cubed, and now we have to see if it's differentiable on the open interval, which it is. So now we can apply f prime of c is equal to f of b minus f of a all over b minus a. So let's solve for f of a and f of b. So f of a, f of b. So f of a is 3 times negative 2 to the 4th minus 12. F of b is 3 times 2 to the 4th minus 12. And because this is an even function, they'll be equal. So that's 36. And this is also 36. So now we can plug in all of our values. F of b, so 36 minus 36, all divided by b minus a, negative 2 minus 2, excuse me, not negative 2 minus 2, 2 plus 2, it doesn't really matter because it's 0 anyway, but we set this value equal to our derivative, so 0 is equal to 12x cubed. Now solve for x. Cube root. X is equal to 0, and once again we have to check and see if it's in our interval. It is, so that's the answer.